This video was sponsored by JLC PCB. I've recently found this super cheap OLED display on Aliexpress. It gave me an idea to build a super cheap OLED glasses. It has an SPI interface and is priced at about $1. I think this could be a great gateway to cheap augmented reality, so I grabbed one, especially since the price is so low. So the plan is to order one of these boards, reverse engineer it, and show you how to replicate my work. You are a bit too late since I've already demolished my Aliexpress board. I've got so excited that I pretty much forgot to actually film it in its original state. I've of course mapped all of the traces and components, so all is well. I've also recreated whole board layout in Fusion 360. This will let me easily generate the Gerber files. To generate the Gerber files, you can use the official JLC PCB CAM file. The process is basically fully automated. You just select the CAM file and everything is done by the Fusion. And just like that, the Gerber files are ready for order. You can also get the Gerber files on my Patreon page. Those are ready for the PCB manufacturing. Now you can open the JLC PCB website and order the boards. Just click Add Gerber file and select the correct zip file. This process is fully automated as well. You don't need any technical knowledge to order the PCBs. You can of course change the board color and thickness. As you can see, the price is super affordable. So now you can click Save to Cart and place the order. Here you can select the shipping address and select the shipping method. After that, select Review before payment and Submit order. The package, as always, came very quick. Everything is packaged neatly in blue cardboard box with JLC PCB logo on top. I think I have like a million of boxes at this point. As usual, I've ordered two versions of my design. 0.1, which is the control group, and 0.2, which is modified version. Here is the 0.1. As you can see, it looks very similar to the original Aliexpress board. It's a very simple in design, but the factory made a great quality job nonetheless. It was super cheap too, priced in under $2 and made in under 48 hours. The 0.2 version is slightly sleeker looking. I've removed the mounting holes, fixed some minor mistakes and changed the layout a bit, which made the board overall smaller. Both of them should of course work exactly the same, since I didn't change any components, at least for now. I will start the assembly process with the 0.1 since it's the control group, which means that if this one doesn't work, then the newer version won't work either. Thankfully, I've kept all of the original components in this small Ziploc bag. I'm a bit of a cheapskate, but I just can't help it. I've soldered all of the stuff apart from the display, which has to be soldered with regular soldering iron, because hot air will just melt it. I've also bought a ton of spare displays just in case. The cool thing about them is that you can get them for less than $8. You can also order the board fully assembled from JLC PCB, since it uses the most basic parts. The assembled board may not look super pretty, but it's designed only to see if I got the schematics right. It was super easy to solder, so if you are looking for easy to do electronics project, then I would recommend it. I've hooked my display to the Arduino Uno board and uploaded the test sketch. The test sketch came directly from the display manufacturer side. It's a super simple program that displays a series of images on the display. You can of course put anything you want there, but don't expect any high-def graphics since it's a super cheap OLED display. I've soldered the newer version as well. I wonder if you can connect both displays at once using the same wires. It would basically enable super easy stereoscopic display setup without any need for external drivers and stuff like that. I've connected both boards together using thin Kynar wires. When I was soldering all this together, I wondered how many displays you can connect to each other this way. And just like that, both displays work at the same time without any hassle. This is great news, since it basically means that you can make super simple, super cheap AR glasses this way. I've got this simple 90-degree prism which can be easily used with those displays. The prism reflects the image at exactly 90 degrees, which lets you see the image without looking directly at OLED. When using this method, you can see the display, but you can't see what's behind it. That's why you should use the cube prisms. This is the rainbow one, which is not ideal, but it will work fine with this kind of display. You can see both display and what's behind the cube this way. This is absolutely cheapest and easiest to make holographic setup. Okay, so now let's design something actually useful. I will of course use the prism to mirror the image so that it will be displayed correctly on the combiner piece. I wanted to display in the horizontal mode, since the vertical one isn't very practical. I've designed a simple plastic case which holds the prism in place. I've tried to place the prism as close to the display in order to minimize the optical length. This build of course will require a magnifier. I've got a bunch of those, so I can test out which one works perfectly. All of them of course came from Aliexpress. In this build I will use as many of the shelf components as possible, so that anyone can replicate it easily. The display itself isn't very big, so it doesn't require a lot of magnification. When using the stronger optics, like from the ECX display, the image quality isn't very good. It has a very low resolution, so you can easily see all of the pixels. I've tested all of the lenses, and those two stacked on top of each other works the best. You can easily see what's going on the screen. They are quite big as well, so you can trim it down to any shape you like. I've designed this small plastic ring which will hold both lenses in place. It has perfect dimensions, so nothing will fall out. The lenses are now perfectly stacked on top of each other. I've made a small prototype which combines all of the pieces together. It doesn't have the top cover for now, so the prism keeps falling out. That can be of course fixed very easily. Here you can see what it looks like when connected to Arduino. This time I'm using Arduino Mega, but you can use any other you like. The image is of course mirror flipped. This will make it appear normal on the combiner. I've modified the lens holder, so now it has a socket for the combiner. The combiner is of course made from a bigger piece, so I will have to make a smaller one myself. I've already installed the new lens holder onto the main frame. Basically the only thing left is the combiner. I've cut a smaller one using a precision knife and a Dremel tool. Here you can see what it looks like when looking directly through the combiner. The orange tint is from the protective film. It will be removed later on. I think the combiner is still a bit too long, so I will have to make a new one. I've also made a new lens holder. It has a slightly different combiner angle. This will make the image easier to see. And here is the new combiner. This time it has a rounded edges, so you won't have to poke your eye out. Now it's time to print the final version. I'm of course using the black PLA. Black color traps the light inside very nicely. Both pieces took about 15 minutes to finish. As you can see, the black color looks way better than the blue one. I've also rounded some edges and improved some tolerances. Of course, I'm still using the same display and Arduino. Here is the glass prism. I've got it on Aliexpress for like $1. And here are the lenses. Those were pretty cheap as well. This build of course requires two small self-tapping screws. I will start by assembling the magnifier. Basically both lenses go on top of each other in this small plastic case. First I installed the big one. And now I put inside the smaller one. With the magnifier piece ready, it can now be attached to the main body with two self-tapping screws. It takes some force since you're basically drilling into the plastic. After that, the plastic parts are now finished. Now it's time to put the display inside the plastic case. The display should slide inside easily. There is no need to force it. On the other side of the frame are the hooks for the PCB. Those will hold the PCB in place. And now the prism. Just like the display, it simply slides in. And now the last piece, the combiner. First I will remove all of the protective film. I recommend doing this wearing gloves. This will prevent any scratches or stains. After the film is removed, you can install the combiner piece into the plastic frame. This part have to be done carefully, since the combiner holder easily breaks. I've connected everything and run test program. You can now easily see the image on the combiner. The image is of course upside down. This is because it should go over your left eye. As you can see, now it works perfectly. And that's all for today. Thanks for watching everyone, and hope to see you in the next video. Currently I'm trying to make as many videos as possible, so if you like this kind of stuff then consider subscribing to my channel. Again, thanks for watching and goodbye.